Good day, everyone. I hope everyone is doing well today. Let's continue our talk about organic molecules. Most medicines, in fact, all medicines that I can think of are organic molecules. Now, one challenge of making medicine, of making specific medicines, is that when you are customizing a molecule, it needs to be perfect, right? If you have this giant molecular chain and you mix up where an oxygen is, you can go from something that is helpful to something that is super deadly. So you have to be super careful with these two molecules, even if they are the same, if they have the same chemical formula. They, because of that difference in structure, completely different. And we have a very special name for two molecules with different structures. We call them isomers. So by definition, any two isomers are, or any isomers really, any substances with the same chemical formula but different structural formulas or structures. Let's look at some examples. So let's look at the formula C4H10. Now, hopefully you recognize that as butane and alkane because of its formula. We could draw it like this. Right? So this would be butane. But there's another molecule that looks like this that is not butane, or looks similar to this, has the same chemical formula. This is still C4H10. However, this is not butane. We would call this 2-methyl propane. Right? So these two molecules are two different isomers. Another example. There are 3 isomers of C5H12. First one is always 4, 5. This one is pentane. The next one is 2-methyl butane. And the last one is, well, let's take a look. The longest non-continuous carbon chain is actually 3 or 3, whatever it is. So these are methyl groups, and this would be a propane, but we can't call it methyl propane because methyl propane not only is it an isomer, it's not even an isomer. 2-methyl propane is just a different molecule, different formula, right? This is C4H10, this is C5H12. So we have to add to this name actually. So what we're going to do is we're going to tell us not just that there's one methyl, but there are 2 methyl groups. And to do that, we add 2 things. Number one, the location of the methyl groups, and number 2, how many there are. For example, this we would call 2, 2 dimethyl butane. This is the location of the methyl groups. The di tells us that there are two of, and the methyl tells us what the side chain is. 2,2-dimethyl, right? So when we are using these multiple prefixes, di means 2, tri means 3, tetra means 4. You could use mono for 1, but you don't have to. 5 is penta, 6 is hexa, 7 is hepta, 8 is octa or octa, 9 is nona, 10 is deca, 11, I forget what it is. 20 would be dideca. So a dodecahedron has 20 sides, right? But we're never going to really do more than 2. So let's look at some more examples of how we use these prefixes. So look at 1,3 butadiene. So this is a little bit tricky because the ene at the end tells us the double bond, but this is telling us where it is, right? So we would read this by, there are 2 enes, 2 double bonds. One is on the first carbon, one is on the third carbon, starting on the third carbon. So the first thing I'm going to do, if it is but, that's 4. 1, 2, 3, 4. One double bond starts on the first carbon. One double bond starts on the third carbon. Then I have to join my hydrogens. Oop, too many hydrogens. So there you go. The other isomer of this, 1,2-butadiene, like that. Right? Not super hard. Let's try some more. 4, 5, 6. How would we name this? Well, the longest carbon chain in a row, 1, 2, 3, 4, 5, 6. So I know it's a hex, and I see these methyl groups, and I see 3 methyl groups. Note that this is not a prop, because we're going to say that this is part of the long chain, right? Because this is part of the long chain, or this is the long chain, these are offshoots. F means a straight line. This is not F because these are 2 non-straight pieces, 2 dots, right? There are 3 of them. So we're going to call this 2, 2, 4, right? Because if that is 1, that's 2, 3, 4, 2, 2, 4, tri-methyl. What did I say? 6. 1, 1, 2, 3, 4, 5, 6. Hexane. All right. Let's do one more. This one's gonna be a little bit complicated. How do we name this? Well, for this one, there are two different things. Here's my main chain. Inside of my main chain, this is double bond, and there's also a methyl group. So let's look at this. 2-methyl, comma, 3, 1, 2, 3, 4, 5, butene, right? Not super hard. So that's how we can use the number system, multiples all together. We can make infinite possibilities. There are literally infinite possibilities because these carbon chains can go hundreds and thousands of carbons long. So thank you so much for watching, and I'll see everyone in class. Bye.